Very good morning. This is Saravanan. Today I am going to take a small lecture on law of motion. Some small tricks to solve the answer, to solve the question in a very short time. Okay. So on the topic of law of motion. So we know very well this from laws. The first law, second law, third law. So law of inertia, the property of offering resistance to the external force, that inertia, and the second law, rate of change of momentum is directly to separate force, and third law about the pair of action reaction in different bodies, that we know the basics very well. So to writing these laws, don't waste the time. So I know that formulas, and from the laws we deduce the formula we know very well. F equal to ma. Main thing, we need application point of view. It is very important to know how to use, where this formula is applicable. So F is equal to ma, one formula, and F equal to, that means F is equal to dv, m into dv by dt, and v into dm by dt, and third is F is equal to m into g plus a. Sorry, these are the three basic formulas in law of motions. So where the mass is fixed and velocity is changing, that time we can use this formula. Where mass is fixed and velocity is changing. For example, if I throw a stone from my hand, the mass of stone is not changing anywhere, but the velocity is changing. So while releasing from my hand, the velocity is higher, and velocity is reduced and getting down. That's all. So that means this velocity is changing, but mass is fixed. That time we can use this formula. And here F is equal to v into dm by dt. Here this velocity is fixed and this mass is changing. Where we can use this formula? For example, rocket firing. This rocket has to fire with a constant velocity. Okay, the velocity, the speed of the rocket is fixed, the velocity is fixed. But for that we need a fuel. How much fuel I want to store? That time we can use this formula. This formula is useful because of the velocity is fixed and the mass of the fuel is reducing. So this formula is useful to know the mass of the fuel, to know the changes of fuel, how much fuel we needed. Okay. And the third one, F is equal to g plus a. This formula, when we have this application, this formula is, here frame of reference is fixed frame of reference, accelerating frame of reference, for example, a lift or elevators moving upwards or downwards, that time you can use this formula. I can differentiate like this. Right, so these are the first initial framing of formulas. There's three major different formula here, and there's a small difference between this formula. That's all. Okay, now I'm going to explain some short tricks in application point of view. For example, we know that pulley concept. So this is consider that 10 kg of mass is hanging and 20 kg of mass is hanging here. So we need to find the acceleration. This is the situation we're having. So in this situation, what formulas I have to use or to apply for this question? Because we know very well the acceleration, because of higher mass, the acceleration is downward, right? So acceleration is downward very well. Okay, what is the this acceleration is due to what? This acceleration due to the unbalanced forces between. So unbalanced forces, here is 20 kg, here is 10 kg. Because if the mass is equal, there is no unbalanced forces because of uneven masses. So here 20, here 10. So this is the unbalanced forces. This unbalanced force causes acceleration. Okay, that means we know simply F is equal to ma. This is the formula can you apply here? And acceleration is equal to force by mass, and this force is 20 minus 10. This is the force acting here, 20, and here is 10 divided by total mass. Total mass is 30 kg. And this total setup in effect of gravitational force. So here is I put it is 10. G is equal to 10. So here 20 minus 10, 10 into 10, 100. 100 by 30, we can take this 10 by 3, 3.3 meter per second square is the acceleration here. Very simply we can use this. And second, this one, the same concept, the same formula and everything is in the second concept. That means, let us assume this is some 6 kg mass lying on the table, So, in this side 3 kg is mass and this side 1 kg is mass and 6 kg is resting on the table. So, here the same formula, there is no change. F is equal to ma and acceleration is force by mass. So, now this is 3 kg, this is 1 kg. So, we know very well acceleration is this direction, no doubt. So, anyway, we are going to find out the acceleration only. So, here, this unbalanced forces causes this, two masses are reason. Because the 6 kg is resting on the table. The 6 kg is resting on the table. So, we not use this mass. So, for example, the unbalanced forces which mass is hanging are in the inclined plane. This two masses hanging, here 3 kg, here 10 kg. These two masses only exert a force. So 30, that means 3 minus 1 divided by the total masses. 1 plus 6 plus 3, that means 2 by into gravitation 10. Acceleration is equal to 2 by 10 into 10. So this acceleration gives 2 meter per second square. That's all. So there's a small difference here. This total setup is in the gravitational, so I can use this both the masses here. This 6 kg is resting on the table, so I am not using here. This 6 kg is balanced by the table. So I am not using this 6 kg in the unbalanced forces. Only I am using total mass, this 6 kg is included. That's all. This is a small difference. And the same, this and the third one is in an inclined plane. Forces in the same concept. Okay. The same concept, everything is same. I put a 6 kg here. I connect a pulley here. Three kg here. Alright, here I put 1 kg, here I put 3 kg here. Okay. So, first model is in that, and this is second model, this is third model. So, inclined plane. What is the force exerted by the inclined, by the mass in the inclined plane is F is equal to m into mg sin theta. For example, let's consider 30 degree. So, mg sin theta is the force. Due to the force only, this mass is moving. Mg sin theta. So, here 6 kg is a mass here and 3 kg and 10 kg. Sorry, 1 kg. Here is excess 10 Newton. Here is excess 30 Newton. Very good. Okay. In this concept, we need to find out the acceleration. Same concept, there is no difference. Acceleration is equal to force by mass. So, force by mass. Force, what is the force acting here? Simply, what are the forces acting here? So, mg sin theta is a force acting here. So, simply mg sin theta. M is 6, g is 10 and sin 30. Sin 30 value is 1 by 2. So, 5, this gives a 30. So, 30 and this except the 30 Newton. So, total 60. Here, opposition force minus 10. These are the unbalanced force here. So, 60 Newton and 10 Newton acting this side. So, 60 minus 10 and the total mass is again the 10. 6 plus 3 plus 1, 10. So, 50 by 10 is gives 5 meter per second square acceleration. So, these are the various small changes we have to. By considering these changes and observe what is using here. So, where using full gravitational pull and is in inclined plane mg sin theta and resting on the table, we are not using this anywhere because it's balanced. There is no unbalanced forces. From this little bit we can understand the concept. We easily solve the problem within 1 minute. Okay.